Hello friends, myself Dr. P.D. Shirbhate, Assistant Professor in Department of Physics, GS Gawande College, Umarkhed. Today, in this lecture, we discuss about a very interesting topic, that is laser. In this lecture, initially we discuss about the introduction about laser and few basic principle. After watching this video, student will learn about how the laser light source emit the light radiation. Student will understand the basic principle of laser physics, and they also understand the difference between the light radiation or light emitted by the ordinary sources and the light emitted by the laser source, and many more. Friends, we all know that laser is a artificial source of light which emit the light radiation which is very different from the other ordinary sources, as laser acronym for light amplification by stimulated emission of radiation. Laser is a source of light which is an artificial source of light which emit the light radiation which is very different from the other ordinary sources. To understand the basic principle of the laser, we have to understand the interaction of light radiation with the matter. We all know that matter consists of different atoms and molecules, and they all are distributed in a different energy level according to their own energy. For our convenience, we consider the two energy level. Suppose energy level E1, that is the ground energy state, and energy level E2, that is the excited state, and we discuss the interaction of light radiation with the matter. In that interaction, we have to discuss about the three main quantum mechanical process, such as absorption, spontaneous emission, and stimulated emission. Initially, we discuss about the absorption. Friends, now consider this diagram. In this diagram, we consider two energy level E1 and E2. Initially, atoms are present at the ground state and excited state is completely empty. When the photon having the energy h nu equal to E2 minus E1 is incident or it interact with that matter, then the atom present in the ground state absorb that photon and goes to the excited state, that's shown in the diagram B. Hence, there is one transition, that is there is a transition of atom from ground state to the excited state. That transition is called as a absorption transition or induced absorption or the stimulated absorption. Now here, initially the photon having the energy h nu will be equal to E2 minus E1 is incident on that material, that will be absorbed by the atom in the lower energy state and excited to the high energy state. If you want to represent this equation or this process mathematically, then that process can be represented as A plus h nu equal to A star, where A is the atom present in the ground state, h nu represent the energy of the photon, or we can say photon density, and A star represents the atom present in the excited state. The number of absorption transition takes place in the absorption transition is completely depend upon the few things, such as number of atom present in the ground state. Between that, the absorption transition is depend upon the how many number of atoms are present in the ground state. Second, it depend upon the photon density, that means how many number of photons will be incident on that material to excite the electron or atom to the excited state. And hence the number of absorption transaction takes place in a given time interval, suppose say delta t, is represent as NAB, where NAB represents the number of absorption transition, which equal to B of 1 to N1 into rho of U, that is the density, into delta T, where A N of AB represents the number of absorption transition takes place. B of 1 2, where suffix 1 2 represent the transition is takes place from level 1 to the level 2, and N1 represents the number of atoms present in the ground energy level, and rho represent the photon density. Now this is the first process, that is first process, quantum mechanical process, which takes place in the when that light radiation is incident. Now we discuss about the second process, that is a spontaneous emission. Now because of the absorption or maybe naturally few atoms are present in the excited state, that's why we consider energy level as shown in figure, where E1 is the energy level in the ground state and E2 is the excited state, and initially atoms are present in the excited state, it is a E2. Friends, excited state is an unstable state, that's why that atom does not accumulate here for a longer time, and they are try to go to its ground state to attain the stability, and hence there is one transition is occur by its own, that is those atoms which are present in the excited state, they take a downward transition after some interval of time, and hence there is an emission of photon. Okay, and that process is called as a spontaneous emission, and hence we define, and this is the spontaneous emission is the emission of photon by an excited state atom by its own without the influence of external agent is called as a spontaneous emission. And the spontaneous emission is mathematically represented as A star equal to A plus h nu, where A star represent the number of or the atom present in the excited state, A represent the atom in a ground state, and h nu represent the photon, energy of photon. And the number of spontaneous emission transition takes place during this time interval delta t is depend upon the number of atoms present in the excited state, that is n2, and hence it is represented that n of sp equal to a of a21 n2 into dt. Okay, now where n of sp is nothing but the number of spontaneous transition, a21 is the proportionality constant, and where 1 2 represent the transition is takes place from the energy level 2 to energy level 1, and n2 is the number of atoms present in the excited state. Friends, in spontaneous emission we obtain the light radiation, but these all the photons are moved in a random direction. That's why we can easily see that concept in a diagram where all the photons are moving in a different directions, and this process is not controllable process. Now we discuss about third process, that is a stimulated emission. The stimulated emission, in the case of stimulated emission, again atoms are present in the excited state, that is E2, but this atom does not wait for a spontaneous emission. Before that we introduce one new process or new mechanism where the excited state atom can be triggered by the external photon having the energy h nu, and hence the one process is one transition is takes place where the atoms will be moved or electron will move from the excited state to the ground state and emit the photon. In this process two photons are emitted, one is a photon which triggered that excited state atom, and one photon because of that transition, and hence there we obtain the photon, and this all the photon will move in a direction of the incident photon. That's why initially we define the definition. The process of emission of photon by an excited state atom in the presence of external agency is called as a stimulated emission, and the stimulated emission is represented as A star plus h nu is equal to A plus twice h nu, yes, where we all know A star is the excited state atom, A is a ground state atom, and where 2 h nu is the number of photon emitted, and the number of stimulated transition takes place is given by 2 of B 21 N2 rho N2 delta T, where NST and ST represent the stimulated transition takes place in a time interval delta T. B of 21 represent the constant of proportionality where the transition takes place from energy level 2 to energy level 1. Friends, this stimulated emission process is the most important process in our laser, and the light obtaining from the stimulated emission is highly monochromatic, highly coherent, because all the photons are move in a direction of the incident photon where the amplification of photon is takes place. Now this is the third process. These are the three main quantum mechanics process because of which we obtain the light radiation. Now we discuss about the next point, that is a population inversion. Friends, we know that in case of population inversion, or yet we can say that initially we discuss about the normal state. Friends, we know that normally atoms are present in the ground state and very few number of atoms are present in the excited state. That is, the number of atom present in a ground state is n1 is always greater than the number of atom present in the excited state. That is, we can say in a thermal equilibrium condition, n1 is always greater than n2, which is governed by the Boltzmann's equation, that is n2 by n1 is equal to exponential of delta E by kt. But to achieve the stimulated emission, we require more number of atoms in the excited state, and when the more number of atom will be shifted to the excited state by applying some other energy sources, then one condition is reached where the number of atom present in the excited state is more in number as compared to ground state. That, or in that case, we can observe that the population of the state is completely inverse than the ground state. Now we can compare this statement according to the given diagram. Initially, number of atoms present in the ground state is more, but when the population is get inward, then in that case the number of atoms present in the excited state is more in number as compared to ground state n1, that is n2 is greater than n1, and hence the population inversion is a condition in which population of the upper energy level n2 far exceed than the population of the lower energy level n1. That condition is called as the population inversion, where n2 is always greater than n1. Lastly, we discuss about the one more definition, that is a metastable state. Friends, to achieve the population inversion, we require more number of atoms must be present in the excited state. It means that we require one energy which can accumulate the electron or accumulate the atoms for the longer time. That type of state is called as a metastable state. Therefore, metastable state can be defined as a state where excited state atom can remain for a longer time than the normal excited state. That state is called as a metastable state. Atom in that state, atom can stay in a metastable state near about 10 to the power minus 6 to 10 to the power minus 3 second. This is the 10 to the power plus 3 to 10 to the power 6 time longer than the time of the stay of atom at excited state. These are the few definitions about the metastable state. Now for this I use the reference which is given here. Thanks for watching this video. Thank you.